So what is prompt engineering? Prompt engineering simply is the art of asking the model question the right way. Hi and welcome back to my channel. As usual, my name is Debola Ibiyode, and today we will be talking about fine-tuning and prompt engineering. In our last episodes in the Demystifying AI series, we talked about embeddings and hallucination in AI, and I've talked to us about what embeddings are, the difference between embeddings and tokens, and how they both help the AI to understand how to reply or respond, and also what hallucination in AI is, why it happens. And I also did bust the myth of the 1 million token context windows in LLMs and why they don't necessarily reduce hallucination as well. Now, following up from that series, we will now be talking about two key techniques that also help in reducing hallucination as well. And these two techniques seem to confuse a lot of developers, and the reason why we need to go into it today is to help us to know when to use which while we build our AI systems as well. Now, fine-tuning and prompt engineering are key AI techniques that help the large language model to be more efficient. Okay? Now, as I've always said, our advancement in artificial intelligence right now is largely centered around large language models and the ability or its capability in processing natural language. And with that comes with some not so favorable outcomes, which we refer to as hallucination in AI, where AI just makes up nonsense. And because the way AI systems are being, or LLMs are being trained, they're trained to speak authoritatively. So even when it has made up a fact or is saying nonsense, it says nonsense confidently. Okay? And that is very misleading, and it's a key thing that we need to tackle in our AI systems. Fine-tuning and prompt engineering help in making the response from AI system more efficient. And because they're quite similar, they tend to confuse a lot of developers on when to use which. And the reason is their similarity makes it the main reason where people just feel, oh, I have to implement fine-tuning to be able to influence my model behavior. But then you could just have tweaked your prompt as well without the investment into fine-tuning. Okay? And it can be argued the other way, where people say, oh, let's not invest too much in fine-tuning and let's just tweak the prompt, when investing in fine-tuning for your use case could have been better rather than tweaking the prompt. Because with tweaking the prompt, again, what tweaking prompts on domain-specific systems can lead to is it increases the stochastic nature of LLM as well. And when I say stochastic, the dynamism in how it responds as well. Because when you tweak it, you might tweak it for a certain type of question, whereas for other types of questions, you may have, left that out. And so it just randomly generates something for those questions that does not meet the prompt structure that you've set. So understanding when to use which is very critical. Now, before I talk about both prompt engineering and fine-tuning, I'll tell us why they're similar. Because again, it gives us I like to give a foundation, right? So we can build on it effectively that way. Now, their similarity, I've said, is that they both shape the model's behavior. So they influence how the model responds when a user asks it a question. Another similarity is how they both influence the model's behavior. They influence it by giving the model examples or instructions. Okay, so you give a model an example to say, oh, respond as an engineer or respond as a customer support expert or something. Both fine-tuning and prompt engineering give the model the example or instruction on how it should respond. The difference is in how both of them give the examples. For prompt engineering, the example is given at query time when the user asks a question. So it's part of the instruction or the user prompt and system prompts passed to the LLM to help it respond at the query time. For fine-tuning, the instructions and examples have been fine-tuned into the model in advance. Okay. Another thing I think I mentioned that is they both aim for efficiency in the response of the model as well. So they help the LLM generate outputs that are more accurate, that are relevant, and well aligned to the user's question. So, for example, if it is a customer support question, right, the AI system needs to reply as a customer support expert. So prompt engineering helps and fine-tuning both help the AI model to respond appropriately as a customer support expert in a customer support task. Which also leads to the next similarity, which is they're both task specific. So you fine tune an LLM for a specific task. You prompt an LLM for a specific task. And the task could be respond as a medical expert, respond as a legal expert. With fine tuning, you would have fine tuned the model in advance with legal. So let's say it's a legal expert in this case. You would have fine tuned the model with legal document, so he understands the tone and the style of how to respond as a legal expert. He also learns the wordings of how legals speak as well. So the terminology, legal terminologies and all of that. So once you fine tune the model with legal data to affect the tone and the style, it is able to respond to you as a legal expert. Same way, you can also tweak your prompt, letting the LLM know when you're respond like a legal expert as well. So both of them are task specific, and they also shape the tone and the style of how the LLM responds as well. So I hope that is clear. Now, I will go quickly into helping us understand when to just tweak our prompt and when it is worth investing in fine-tuning a model. In addition, towards the end, so wait till the end, I'll also bring in another technique, which is the RAG technique, and help us understand the difference between fine-tuning and RAG as well. Because fine-tuning sometimes sits in the intercept between helping the LLM understand the tone and the style to respond, and also giving the LLM ground truth on a specific domain as well. So fine-tuning sits in that intercept, but it is different from what RAG is. So I'll briefly towards the end, so wait till the end and I'll tell us the difference between fine-tuning and RAG as well. So what is prompt engineering? Prompt engineering simply is the art of asking the model question the right way, right? Or helping the model to understand the user query better, giving the model context of that user's query and how they should on how the LLM should respond to the user properly. Okay, so it is an art. So prompt engineering is not a science in a sense; it's an art. There are some prompt engineering experts out there, but I would say the more you use chatbots, the better you are at prompt engineering. In some cases, right? But there is a lot of iteration when you go into LLM ops, which is the operations of LLMs within a system, and you have to use different LLM prompts in your process. There's a lot of iteration engineers go through in tweaking the prompt appropriately, and that is an expertise that is quite valuable in our world today. So if you're looking into a career, I don't think people look for prompt engineering experts in that sense, but having expertise in prompt engineering is quite useful for you as well. So prompt engineering is an art of ensuring that your model is asked the question the right way. So an example I will give, and I used that when I was trying to prepare for one of my episodes, is rather than ask an LLM, say, explain embeddings. You could just say to it, explain embeddings in plain English to a non-technical professional. See, that's an instruction you've given the LLM in your prompt, right? So you say, explain embeddings in plain English to a non-technical expert. Now, what the LLM is going to get, or the model is going to get, is A, I don't have to go into a lot of technical details in my response because my response is to a non-technical expert. B, I should also not be using technical jargons because the instruction says explain in plain English. Once you give that in that prompt, the response will be appropriate for that user based on the instructions in the prompt. Another example is, say, you are a data analyst, right? You can have a basic prompt to say, summarize this sales report, and you upload your sales report. Now, what's going to happen is the model is going to generate a generic summary and it misses some key points because you've only used two phrases. Summarize, well, not two phrases, a short sentence. Summarize this sales report. It's just going to give you some generic answer. But when you apply prompt engineering, rather than say summarize this sales report, you could say summarize this sales report in plain English for executives, highlighting revenue trends, customer churn risk, and keeping it on under 5 bullet points. You can see I've given it more instructions. So there is no way that the output at this second iteration will not be better than the first iteration. You can try it out, right? Open an LLM chatbot, could be ChatGPT, Claude, Gemini, any one of them, right? And type in, just give it some report that you may have. Summarize this sales report. Get the answer, right? And then write another prompt after the response to the first instruction you've given it, which is the first prompt, because prompt engineering is you giving the LLM instruction, right? Now, once you get that output, you can ask a follow-up question or ask another prompt, write another prompt and ask the LLM this way. Summarize this sales report in plain English for executives, highlighting revenue trends, customer churn risk, and keeping it under 5 bullet points. The output will be more concise, board-ready summary focusing on exactly what decision makers need to see. Okay, so prompt engineering is how you get the best from the model, from the LLM. All right. Another example quickly is, let's say you have a legal or compliance contract. Someone sent me a contract, and I just because I get a lot of contracts sent my way sometimes, I just ask the LLM to summarize it. Now, if you say to an LLM, summarize this contract, it's just going to give you some long generic summary with a lot of legal jargons. Now, I don't know legal jargons, So what I would say is summarize this contract in simple language, focusing on obligations, penalties, and renewal terms in less than 200 words. So basically, I've asked you to give it to give me a summarization that is best for me. Okay, so prompt engineering helps you give the LLM instructions that help the LLM produce an appropriate output for you as well. So I would summarize what prompt engineering as this. It is about framing the task that you want the LLM to perform so the model gives you the right output for the right audience. So the knowledge is already in the model, as we all know. You just need to ask the model the question the right way, giving it enough information just so that it can respond to you appropriately. Okay, so that's what prompt engineering is. Now, what is fine-tuning? Fine-tuning is you training the model on more information. So let me find an easier way without saying technical jargons to define that for you. So fine-tuning is when you train the model with your own data. And this is what I'm going to talk about RAG towards the end quickly. Now, when you fine tune the model with your own data, instead of you relying only on generic training that the model already has. So large language models are trained on a lot of data set, but they're all generic. So rather than that, you can give that model, you fine tune it with your own data, giving it examples in your own style or in the domain that you want it to be an expert on. So for example, you can fine tune GPT, one of the models of GPT, on thousands of customer support transcripts. So it sounds like a customer support expert. Okay, or you could fine tune it on, I don't know, chemistry research paper, so it sounds like an expert on the subject matter around chemistry. So what fine tuning does is, rather than you prompting outside of the model, you are actually in a way giving the instructions in the model to be part of the model. So you fine tune your own data into the model, where the model becomes a domain specific expert in the data that you fine tune it for. So that is it. So fine tuning doesn't change instructions. It only just changes the model's underlying behavior, because GPT no longer is the general GPT. It now becomes a domain specific GPT based on the data that you fine-tuned it with. Okay, so it doesn't still mean that you don't need to prompt it, but you've already changed its underlying behavior to respond as an expert in that domain. So when prompt engineering is enough. All right, so this is one thing you need to know. So I'm moving away. I hope you understand what prompt engineering is and what fine-tuning is, right? Now we're going into when prompt engineering is enough. Most of the time, prompt engineering actually does all that we need. Most of the time, to be fair. Yeah, fine-tuning can be an overkill in most cases, right? Because the large language models, especially with all the iterations that all of these AI model companies are bringing out there, they're quite good as they are. Now, most of the time, we can use tweak your prompt and you get the expert that you want from the LLM. If what you are after really is to get the LLM to speak in a certain tone, to respond in a certain tone, use prompting. Okay? If what you want is a step-by-step explanation, right? So you want the LLM to be more detailed oriented in a certain domain, use prompt, right? So because you want a step-by-step explanation of how something happens. So as a chemistry research paper, right, or chemistry research experts rather, you're giving it a chemistry research paper, you can just, it will use your prompt. You give it instructions on how it should explain the response in a step-by-step manner. So you can use prompt for that. If you want the answer in another structure, so let's say you want it to be in, say, a tabular form or in a JSON form or a structured output, you can use prompt for that. So if the model already knows the information, or you have augmented the model's information with something called RAG, right? Which is you've externally passed into the model data as its context in responding, right? So if you've already done that with your model, then you do not need fine tuning. You just need to ask the model the question in a better way. Okay, so basically, if your model already has the information it needs, or you're able to implement RAG to augment your model's understanding, you don't need to fine tune. You can just use basic prompt. All right, so that is when to use prompt engineering. So quickly, when is fine tuning worth it? Fine tuning makes sense when you need specialized knowledge or domain specific knowledge that is not in the base model. So if I did say something in I think in a conversation, and there's an article that I wrote, I don't think I published it yet, but I will be. But it's around our pursuit of artificial general intelligence. Is that where we should be targeting, or should we be pursuing artificial domain intelligence. Because in our world today, we need AI to solve our current problems. And for AI to be good at solving our current problems, it has to be domain specific. We have to build its domain intelligence, right? Now, if you're trying to build a domain intelligence system, fine-tuning that is when you should be looking into fine-tuning as well. If you need your model to be able to also respond in a consistent style, okay? So if you're building a medical AI system, for example, you want the model to always respond in a medical style, you need fine-tuning at that point in time as well, because it makes it consistent for the model. Another way is if you want to teach the model new formats, so say domain-specific jargons or terminologies, use fine-tuning as well. So those are when to use fine-tuning. And if you don't want to fully fine-tune, right, there are other ways you could do it as well, because I do know the fine-tuning is quite expensive, so it depends on the type of system that you're building. I also find that a combination of prompt engineering and retrieval-augmented generation can also be a cheaper combination to fine-tuning as well. Okay, so because with RAG, right, RAG helps give the model domain specific information as well. It was not fine-tuned into that model. Now, what RAG does not do is RAG does not ensure that the model is responding in a consistent style, right? However, if you've given the model, the RAG information, which is the context, your own data, but you didn't fine tune it was passed to the model at the query time. Okay, what you're giving to the model there is also, you have taught the model some domain specific jargons as well, because you've given it some domain specific information, context at the time it's able to respond. What the RAG will not do is it will not ensure that the model is responding in a consistent style. However, you can use prompt engineering to ensure that the model responds in the style that is specific to that domain as well. All right. So if you don't want to invest too much in fine tuning, you could get away with a combination of very good prompt engineering and very robust RAG system. Okay. But you could also say, can you do fine tuning and RAG? Okay. So now let's go into that. Fine-tuning versus RAG. Now, here's another confusion that people also get. I did say that fine-tuning is at the intersection of passing ground truth to your model and also ensuring that your model is able to respond in a consistent tone or style, right? So fine-tuning is kind of playing at an intersection between prompt engineering and RAG in a way. And so it brings in that confusion, because at some point people will say, oh, instead of using fine-tuning, just use RAG, but they forget the prompt engineering aspect of it. If you don't have a robust prompt engineering within your LLM ops, using just RAG does not replace fine-tuning. You're better off just fine-tuning. But fine-tuning in itself is not enough. All right. So this is what I want us to say. To solve different problems, you apply different AI techniques. For fine-tuning, I would say that fine-tuning, what it does is it teaches the model new styles or new skills. For example, writing in your company's voice. So let's say, I don't know, you're an insurance firm and you provide support to your customer and you have a standard within your firm on how you want your employees or people working for you to respond. If you have an AI system, you will be building that standard within that AI system as well. Now, fine-tuning helps to ensure that the model understands the insurance terminologies or jargons, and it helps you teach that model your skills or style of responding as an insurance expert. So that's what fine-tuning really does, okay? Even though you've passed the data to it, it doesn't really use it as context in that way. It uses it to understand how to respond. Now, RAG on the other hand gives model new facts, grounded truth, context, right? While it's responding. So the model is not retaining that information. It's just using it as its ground truth at the point of responding. All right. So it's giving the model facts at the time of responding. So for example, when you're asking it to answer a question from your private database, you just pass that data to the model at that time so it can respond. So if you wanted it to give you what are the top 5 products in skincare, right? It's going to go into your private database to see the top 5 products with the most revenue, right? And then, but it's a RAG that can do that, get that data. You could use SQL or whatever tool, package it, and pass it to the model as external facts that it uses as ground truth in responding to the user as well. So that is the difference between both, right? So they both don't do the same thing in that way, but they both help in how the LLM is able to answer and the facts that the LLM rely on in answering the question. So it then comes, can you use fine-tuning and RAG at the same time? Yes, if you've got the investment, you could. Right. And it could mean that your prompt engineering might not, you could get away with simple prompts within your LLM ops if you have a combination of fine tuning and RAG together as well. So again, just to do a quick recap, use prompt engineering when you want to pass the instruction at runtime, when you want it to be able to provide a step-by-step explanation. So you give the LLM instructions at runtime on how it should respond. And when you want it to respond in a certain structure or produce an output in a certain structure like JSON or tabular form. You use fine-tuning when you want your LLM or your model rather to behave as a domain expert. And the reason for that is it should respond in the fashion and the style and the terminologies of that domain appropriately. RAG can be used with both prompts and fine-tuning, depending on what investment you have to play with. Hope that is clear. Cool. So when should you use which? I think I mentioned that. If your issue is knowledge refreshness, I'm talking about fine-tuning versus RAG now, because I think it's a good fact. It's why I like to write things down. Because when you speak off your head, sometimes you miss some key points. So when should you use fine-tuning or RAG, right? If your issue is knowledge freshness or grounding, use RAG. If your issue is behavior, tone, or specialization, use fine-tuning. If your issue is both, you can combine both fine-tuning and RAG. Now, if you have limited investment, you can replace fine-tuning with prompt engineering. Okay? But you have to be quite effective in your replacement in that way. So here's a simple way to remember everything. Prompt engineering is like writing a better recipe for a chef. Okay? So you have a chef and you want it to be able to use a good recipe. You can have prompt engineering do a step-by-step explanation of that recipe. Okay? Fine-tuning is like training the chef in new recipes. Okay, so the chef can cook filet mignon, and you want to teach it jollof rice. you can use fine-tuning to do that. All right. RAG, on the other hand, is like giving the chef the fresh ingredients on demand. So basically, when you ask the chef to say cook jollof rice, you pass the ingredient that is required, right, for jollof rice at the time to that chef, and how it should, with some data around how it should cook it at runtime as well. Okay, so RAG is like giving the chef the freshest ingredient on demand. So each of these techniques do have its place. Each of these techniques can be used interchangeably within each other. They both, for as long as you understand what each do, you will know how best to apply which and when and in what order. All right. So, okay. Quickly, I'm always trying to reduce my video. I think we're on 32 minutes. So when should you use which is the first question I ask. So I would say if you're building an AI system, it's best for you to start with prompt engineering. Don't do the big investment yet, okay? If you need fine-tuning, you will know as your product evolves, okay? So I will always say start with prompt engineering. It's fast, it's free, and it's often usually enough for most cases. Use RAG when you need real-time facts and on external knowledge. And RAG is not expensive as well. So you can use RAG when you need facts. If you need your LLM to only reply on facts, use RAG. Now, you should then think of investing in fine-tuning when your product has evolved enough to that stage and you require consistency, tone, and domain expert style in your responses as well. Okay? So that is when to use both. Cool. So that brings us to the end. So next time, I think we will be talking about, I don't know what to pick yet. I have a couple of topics. The difference between an AI product and an AI model. Because I still get people confused in it. So I don't know. Maybe I should do a quick episode on AI product versus AI model and what's the difference. Or we could look at model size versus model quality. Why bigger isn't always better. You know, you can leave a comment below on which of the topics you want to see next. The first one will be AI product versus AI model. Are they the same? Or model size versus model quality. Why bigger isn't always better? All right. Let me know below which of the topics you want to know, or you can send me an email or DM as well. Cool. So that brings us to the end of today's episode. Thank you as usual. And remember, we are here to demystify AI one concept at a time. Thank you for joining me as usual, and see you next time. Bye.